Welcome everybody. This is our second session on data warehousing, and now we'll be having a detailed insight into data warehousing. We'll be covering subjects such as what is data warehousing architecture, the ETL process, that is the extract transform read process behind a data warehouse engine, the strategic information systems, why do we use strategic information data warehousing, how strategic information is different from online transaction processing or operational information which are used in traditional databases, and what is the blend of technologies in a data warehouse, and also the architecture of data warehouse system. Now, in computing, a data warehouse or data warehouse, also known as enterprise data warehouse, is a system used for reporting and data analysis and is considered a core component of business intelligence. Data warehouses are central repositories of integrated data from one or more disparate or heterogeneous sources, which I told in the last session also. They store current and historical data in one single place that are used for creating analytical reports for workers throughout the enterprise. The data which is stored in the warehouse is uploaded from the operational or the OLTP systems or the traditional databases such as Oracle or DB2. Okay, it could be a marketing or a sales database. The data may pass through an operational data store and may require data cleansing, that is removing the inconsistencies or the noisy data or the data which is not accurate, for additional operations to ensure data quality before it is used in the data warehouse for reporting and query generation. Okay. Now, if we see it, data warehouse has been defined very clearly by W. Inmon. He defined data warehouse as follows: that data warehouse is subject-oriented, integrated, non-volatile, time-variant collection of data in favor of decision making. Now, these are the four characteristics of data in a data warehouse. Number one, data is subject-oriented, integrated, non-volatile, and time-variant. We already discussed these characteristics in our previous session. Whereas on the other hand, Kelly said that data warehouse is nothing but a separate, available, integrated, time-stamped, subject-oriented, non-volatile, and accessible. So, data warehouse is architecture for organizing data, a subject-oriented, integrated, time-variant, non-volatile collection of data in support of information systems. It stores tactical information answering who did this, what is the data, or what is the summary of the data, or what is the summary of sales data from say January 15 to May 15. So you could be having any type of summary, and who has collected data, whether it is the person collected data, is he from the north zone, has he collected data from the south zone, or what type of zone, or maybe a particular region only. So a query submitted to data warehouse might be: what was the aggregate construction loan outstandings between January 5 and May 15 for the 10 largest branches in the third lending district. Now, this is just an example of a query, and this is what information we get from a data warehouse. So, data warehouses are large databases that are specifically designed for OLAP and business analytics workloads. The data organization is optimized for column-oriented processing. Data is gathered from multiple sources, including relational database management systems, and is cleaned, transformed, and loaded into the warehouse. So we did this already in the last session, that the four characteristics: subject-oriented, integrated, non-volatile, and time-variant. So just you can have a reading of it because we already explained it. Now, data extracted from operational systems are moved into data warehouse at specific intervals depending on the requirements of a business. Now, what we mean by non-volatile is that, data in a data warehouse is persistent. It is not changed. It is not removed. It is permanent in nature. Okay, you don't update it. You don't modify it. You don't create more data. Okay, so once the data comes into data warehouse from various sources, heterogeneous sources, it is non-volatile in nature. It is persistent in nature. Every business transaction does not update the data in the data warehouse. So whatever the business transaction updates are doing, they are being done in the operational database, or we call it OLTP database, because data in a data warehouse has what? OLAP operations. OLAP means online analytical processing. So even the queries which are submitted in the data warehouse system are nothing but OLAP queries. Okay, we'll be coming to this in the third session. So OLAP stands for, I repeat, Online Analytical Processing. The business transactions update the operation system databases in real time, and this updates are fed into the data warehouse system after cleansing of the data. Data from the data warehouse is not deleted in real time, and data is neither changed by any individual transactions in the case of a data warehouse system. So this is what is the thing, but three important characters: subject, coordinate, time, very non-volatile. We already discussed. Like if you say subject coordinate, it is organized along the lines of subjects of the corporation, such as subjects could be customers, could be products, could be vendors, could be transactions, and so on. Now this is what you see. See the OLTP databases. Now I am having this OLTP databases are in various formats. I could be having some data in Microsoft Access, some data in Oracle, some data in Sybase, some data in DB2, and will be integrating all this data into a single format. Okay. Now after the data is integrated, it is cleansed, that is the inconsistent data is removed or deleted. Then we load the data into data warehouse, and this is the last step, loading the data into data warehouse. So I'll tell you that this really add data and change data, deletion data is nothing but operational system applications, also called as OLTP systems. Whereas in the case of data warehouse, we have got what information systems, or to be particularly known as decision support systems. Why? Because the data in a data warehouse supports what type of information? Strategic information. So and whereas the data in the OLTP databases is what? Operational information. Let's take a case study in data warehousing systems. Now this case study is for a garment chain company. Vikram Bajaj is the CEO of a large garment chain called VBR. He asked one of his employees to provide him with a status report on the business, as he wishes to know whether the company was making an overall profit or loss. VBR has approximately 100 stores spread throughout the country. Although this is not a difficult question to answer, the problem lies in collecting the relevant data that is spread across 100 stores. With great difficulty, the employee contacts each and every store and asks the store managers to give a summarized figure describing whether the store is running at a profit or loss. After obtaining 100 such figures, he calculates the cumulative result and gives it to Vikram Bajaj. The problem does not end here for the employee. Vikram Bajaj now wants a detailed product report of the previous year because he wishes to know which products sold out well and those that did not even had a marginal sale. He wants to analyze his sales. Okay, so which were the niche products, which were the average sellable products, and so on. Again, the employee contacts each and every store, and thus the entire process is repeated. Such situations do prevail in a non-data warehouse environment. This is where the concept of data warehouses comes into the picture. In a data warehouse environment, the entire concept of all the stores is stored at one place. Why? Because the entire data is extracted from multiple sources. It is transformed, that is cleansed, and then loaded into a data warehouse at one place. That is one single computer or database server system at the main office. In such a situation, the employee's work would have been very easy, because in that case he would not have required the CEO. He would not have required, because the CEO could have himself gained access to all the data while sitting comfortably on his chair. Some very popular examples of data warehousing. There are numerous cases where we use data warehousing systems. It can be applicable anywhere where we have huge amount of data and we want to see statistical results that help in the decision making process. The most common use of data warehousing is in social media websites. Other uses banking, government, insurance sector, and so on. The social networking sites like Facebook, Twitter, LinkedIn, etc. are based on analyzing large data sets. These sites gather data related to members, groups, locations, etc. and store it in a central repository. So the data being so large, data warehouse is therefore needed for implementing the same. Similarly, most of the banks, if you see, just take a case of State Bank of India, it has thousands of branches across the country. So most of the banks these days use warehouses to see spending patterns of account or credit card holders. Okay, debit card, credit card, so that on the basis of their usage, on the basis of the transactions, if they make huge transactions, the objective is to provide them special offers, details, etc. through online stores or retail stores. Government uses data warehouse to store and analyze tax payments, which is used to detect tax thefts. There can be many more applications in different sectors like e-commerce, telecom, transportation services, marketing and distribution, healthcare, and retail industry. What can a data warehouse do? Number one, immediate information delivery. Data warehouse reduces the time period lapse between the request for information and the actual delivery of information to the users. Integration of data from within and outside the organization. They combine data from multiple sources like sales, marketing, finance, accounting, and so on. Besides, this data is also taken from external sources like business magazines, surveys, etc. They also provide insight into the future because data warehouses store large amounts of historical information that enables the decision makers to analyze the prevailing trends in the market and produce the products or goods according to the customer's demands. Not only this, they enable users to look at the same data in different perspectives and different ways. Our data warehouse system provides its users with tools for analyzing and manipulating data in many different ways. It facilitates the users to drill down into detailed data with the click of a mouse. And lastly, it provides freedom from dependency on IT. That is, there are many users who are totally dependent on the IT people, the people working at IT server and so on. So with data warehouses, users have no longer depend on IT professionals to answer their queries. They can themselves analyze the queries. Sales data by a data warehouse. So this table illustrates how a data warehouse can help its users to analyze sales, like determine sales to take vital decisions regarding price and distribution, determine the success and failure attributes by studying the historical sales data, determine successful products and learn about their key success factors, also understand the profits as well as revenue implications of a decision which has been taken, identify the most privileged, the promising, the niche customers, identify the customers who are no longer loyal to your organization. So you have to tap these customers, they are very important because they should not go to some other organization. Identify the salesperson who have performed extremely well and those who could not work to fulfill the expectations. What can a data warehouse not do? This slide focuses on limitations of data warehouse. It's not a magical box. Data warehouse does have certain limitations. It acts as an information repository that collects and reports data that already exists within a data warehouse system. It cannot create additional data on its own. Let me tell you that I told you data warehouse has got non-volatile data, persistent data. The data which has been collected in the last 5 years taken and fed into the data warehouse system. For example, if a manager wants to analyze the sales of a product based on the income level of customer, and if the income of the customer is not captured by your source systems, by your operational systems, then the data warehouse will not be able to help the users in any way until and unless a mechanism or method is devised to gather the income data. Apart from this, if an organization has dirty or inconsistent or noisy data in its source systems, in that case, the data warehouse will not be able to correct the results until and unless the data is first cleaned. That is, cleansing operation is performed. In this context, a data warehouse will only be able to identify where the problem exists, but corrections or modifications will have to be made in the source systems that capture the data. Now this is a quite important slide because in most of the companies they ask the students of BTech CS or BTech IT or MTech or even MCA that what is data warehouse? Is it an environment or a product? Clear? So data warehouse is simply an environment. It's not a product that enables its users to use the data stored for making strategic decisions. Remember that strategic decisions are very important. That is why you use strategic information systems, also known as decision support systems. So it is an architectural construct of information systems such as DSS that provides users with current and historical information, decision support information that is hard to access to or present in the case of traditional operational database stores. In fact, the data warehouse is a cornerstone of the organization's ability to do effective information processing, which can enable and share the discovery and exploration of important business trends and dependencies that otherwise would have gone unnoticed. In principle, the data warehouse can meet information needs of managers and executives and can provide strategic business opportunities by allowing customers and vendors access to corporate data while maintain the necessary security measures. These managers and executives could be what? Technical analysts, could be business analysts, could be top executives, could be power users or even regular users. There are several reasons why organizations consider data warehouse a critical need. Why data warehouse is critical? Number one, decisions need to be made quickly and correctly using all available data. Number two, users are business domain experts. Remember that your users, especially the people who are good in IT but are MBAs, they are domain experts. They are not computer professionals. They are not very good in computer coding. The amount of data doubles every 18 months, which affects response time and the sheer ability to comprehend its content. Lastly, competition is heating up in the areas of business intelligence and adds information value. So, data warehouse can consolidate and integrate information from many internal and external sources and arrange it in a meaningful format for making business decisions. Now, this slide is important. Why? Because it gives you an entire picture of data warehousing process, in just like an architecture data warehouse. You see the point of sale, the ERP terminal, the legacy system, the old TP systems, and the external web sources such as spreadsheets, etc. These are nothing but operation systems, or nothing but called as old TP systems. So these are the external sources, or could be the internal source also. From there, the ETL process performed using ETL tools, namely extraction, transformation, and loading, which is the last step. And then after this data is loaded into the warehouse, then we create what departmental data warehouses. We have got a data warehouse for marketing department, for sales department, for logistics department, for inventory department, for supply chain department. So these are called as data marts. Now comes the middle layer or tier, where now the data warehouse will have to be fed for what? Performing queries and generating reports to be used by what? Executives. And these queries can be performed using OLAP operations or a ROLAP server. OLAP is online analytical processing. ROLAP is relational online analytical processing. And this queries can be submitted to a web browser. So this is the interface of a data warehousing. Now, as can be seen on the previous slide, the following are the major components of data warehousing process. Number one, data sources. Number two, data abstraction, data loading, comprehensive database or data stores, data marts, metadata, and middleware tools or information data tools. We will be coming to these one by one as we proceed ahead. Now, this was the very first process which was there in the ETL process. If you see, I will just show you the once again. See, point of source, ERP, legacy, these are nothing but the heterogeneous sources. It could be internal sources or external, and then the ETL process done extract, transform, and load. So coming to this, data abstraction, data cleaning and transformation, and loading the data into the data warehouse, which is the last step. Okay, so cleaning and transformation means what? Convert from legacy to the warehouse format. Loading means sort your data, summarize data, consolidate data, compute the views, check integrity of data, build your indexes. Are you getting it? Primary index, secondary index, partition your data. So ETL is the process in data warehousing and stands for extract, transform, and load. It is the process in which an ETL tool extracts the data from various data source systems, transforms it in the staging area. Now this is the staging area. See, the transformation is done in the staging area, and then finally loads it into the data warehouse system, okay, for the business users to access, for the what decision making users to access the data. ETL tools commonly used are Sybase, Oracle Warehouse Builder, Clover ETL, Mark Logic. These are nothing but ETL tools. Now the first step of the ETL process is extraction. Now you see, these are nothing but what? RDMS, some data is nothing but in an RDMS, say Oracle, some is coming from SQL Server, some are nothing but flat files which could be made in Excel, okay, normal files. So the first step was the ETL process extraction, and in this step, data from various heterogeneous sources, which can be various formats like relational databases, SQL databases, NoSQL databases, web databases that are XML, and flat files are done into the staging area. So it's important, okay. So hence loading it directly into the data warehouse may damage it, and rollback will be much more difficult. So therefore this is one of the most important steps of ETL process, what? Extraction. The second step is what? As the name implies, extract, transform, load. Second is transformation. In this step, a set of rules or functions applied on your extracted data to convert it into a single standard format. Now what are the processes involved here? Filtering, cleaning, joining, splitting, and sorting. It is not necessarily all these processes involved, but the most important are filtering, cleaning, and joining. Okay, splitting is what? Sorting could be depending on if your organization is very complex, if the data is very, very complex. Okay. Joining means joining multiple attributes into one. Splitting means splitting a single attribute into multiple. For example, if I say address is one, but I will split into what? Flat number. Are you getting? Street, locality, city, and zip or pin code. Third and final step of ETL process loading. In this step, the transformed data is finally loaded to the data warehouse. Sometimes the data is updated by loading into the warehouse very frequently, and sometimes it is done after long but regular intervals. The rate and period of loading data which has been transformed into a data warehouse solely depends on the requirements and varies from organization or system to system. Nowadays, complex organizations, they use the pipelining concept. Now, what is pipelining concept? That is, as soon as some data is extracted, okay, a portion of data is extracted, it is then transformed, and during that period, some new data can again now be extracted. And while the transformed data is, by the time the transformed data is being loaded into the data warehouse system, the already extracted data can again now be transformed. So this can be seen in the figure very clear. See, data coming from hospitals, from banks, from industry, customer data. Now the ETLs, the extract, transform, load process done, and then presented to the warehouse. So this is very good example and very clear. So data in a data warehouse, when it comes from different sources, these are nothing but sources from where the data comes. What are the benefits of ETL based data warehouse architecture? Now, what are the benefits? Why do we have? What are the advantages we get from the ETL process? Integrate data from multiple sources into a single database. Mandate data history even if the source transaction systems do not. Third, integrate data from multiple source systems so as to enable a central view across the enterprise. Now this is very valuable because some organizations, they 2 or 3 organizations merge into one organization. Okay, so we do have mergers and acquisitions. Okay, like CMC India got merged into TCS. Okay, fine. Now presenting the data warehouse architecture, very important topic. The architecture properties, separation, that is analytical and transactional processing, should be kept apart as much as possible. So transactional processing, what? The data, the daily data, which is nothing but stored in operational databases called as OLTP databases, whereas the data which is fed into data warehouse is nothing but what? Analytical data, that is what? Strategic data. Scalability, hardware and software architecture should be easy to upgrade as data volume which has to manage and process increases more and more. Okay, extensibility, architecture should be able to host new applications and technologies without having to redesign the entire whole system. Monitoring accesses is essential because of the strategic data stored in data warehouse. And lastly, you should be knowing how to administer your data. Now there are 3 layer architecture. Okay, So what is this 3-layer architecture? See, if you see this, the source layer where you have got the data staging, release and then loading, this is nothing but ETL process. Then it comes into data warehouse, are getting, and you do this ETL process, extract, transform, load into using what? ETL tools. Then from the data warehouse we have metadata. What is metadata? Okay, data warehouse for sales, data warehouse for finance, data warehouse for operational data for operations department, data warehouse for logistics department, data warehouse for HR department. So because the department themselves are very big, so the departmental data warehouses are nothing but called as metadata. And then the second layer, and lastly, to analyze the data using OLAP queries, what if analysis tools, data mining tools, OLAP, that means online analytical processing tools, reporting tools. This is nothing but analysis part of data warehouse. Okay. So you see, again see, you have 3 tiers. So the bottom tier, the middle tier, and the top tier. The bottom tier of the architecture is the data warehouse database server. It is the relational database, because these are the sources from where the database will be collected, extracted. So we use the backend tools and utilities to feed data into the bottom tier. These backend tools and utilities could perform the extract, clean, load, and refresh functions on the data, which has to be loaded into the data warehouse. Now, middle tier. In the middle tier, you see we have got the data warehouse server, which we call as the OLAP server. Why? Because we perform OLAP operation on the data in a data warehouse, and we have got either the ROLAP or the MOLAP or the HOLAP model. So relational OLAP, the multi-dimensional OLAP, and the HOLAP hybrid OLAP, which could be combination of ROLAP and MOLAP. This is what you see we have got now. Is simple and simplified 3-tier data warehouse architecture. So this we have done. So extraction, we have already explained you. See what does it mean by cleansing, duplicate data, inconsistent data, missing data. All this has to be removed. Unexpected user fields, impossible wrong values. How can this be a date? Are you getting it? Because you've got a DDMM file format. Okay, so you cannot have this date. Okay, why? Or because it's the month of February, and you see you're having 30th February. So these are impossible wrong values. So this type of data needs to be removed, and that is what is called as cleansing data. Then after data has been cleansing, that is now we load it into a data warehouse. So you can do it in 2 ways: either you refresh your data regularly or you update it. So data warehouse, you see, is a blend of many technologies. Data transformation functions like data extraction, cleansing. Are you getting extraction, cleansing, and what? Loading, okay, or aggregation. So it is fed into data warehouse, and then these are the people who perform queries on the data using OLAP tools or using report generation tools and so on. So this data warehouse users comprise of executives, managers, business analysts, technical analysts, power users, and so on. So you see, data warehouse is a blend of many technologies like data modeling, data acquisition, data quality, data management, metadata management, analysis, that is OLAP analysis, applications, administration, development tools, and storing management. So what are the basic operations of data warehouse? Extract data from the operation systems, include relevant data from outside sources like magazines, journals, reports, remove inconsistencies, and transform and clean the data, store data in such a way so that it is easy access to support decision making. So these are the important functions: data extraction, loading, transformation, data ETL process, storing data, and providing user interfaces. This is just an example of what a different application of data warehousing. You see, for example, retail, customer loyalty, market planning. This could be the applications in retail industry. Financial banking, airlines. Need for strategic. Who needs strategic information? Because strategic information, operational information is nothing but that which is fed into database systems. That is the traditional database systems which normally students study as a part of database management system. But in a data warehouse, the information is strategic in nature. Are you getting it? You don't have, because the tool used for nothing but data warehouse is nothing but decision support system, DSS. So what we mean by strategic information? Now see some examples, objectives. The company wants to retain the present customer base, increase the loyalty of a customer by 15%. Now this is what they have targeted over the next 5 years. They want to increase their customer loyalty by 15%, improve product quality levels in the top 5 product groups. So the company could be having say 100 type of products, but there are top 5 product groups which are most sellable, so they want to improve the quality level, gain market share by 10% in the next 3 years, enhance customer service level and shipments, bring 3 new products to market in the next 2 years. All this is nothing but making decisions about the objectives. Executives and managers need information to get in-depth knowledge of the company's operations, review and monitor the KPIs, means key performance indicators, keep track of how business factors change over time, and compare the company's performance relative to the competition and to industry benchmarks. All this type of essential information is what we call as strategic information, long-term information. So what are the characteristics? It should be integrated in nature, data integrity, it should be accessible, it should have credibility to the user, timely. So when I say integrated, must have single enterprise value. When I say credible, every business factor must have one and only one value. So there should be no misleading value or misinterpretation. Timely information must be available within the stipulated time factor. Now this is nothing but OLTP databases versus decision support systems. Now decision support systems are used in data warehousing systems, and OLTP databases are nothing but operational online transaction processing are used in daily or transactional database. So this is nothing but transactional data, and this is nothing but strategic data. So DCS makes use of what? Strategic data, strategic information. OLTP may use of operational information. So these are attributes, or characteristics on the basis of which we have compared. Data content, OLTP current values, this is what summarized. See, data structure optimized for transactions, but in this it is optimized for complex queries. See, usage predictive. See, there are so many differences. If I say view, OLTP detailed or flat relational databases, but here you have got summarized, and the model of data used is multi-dimensional model. We'll be studying this multi-dimensional model as a topic, as a separate chapter, where you use star schema, snowflake schema, are you getting it? Constellation schema, and so on. So this is a comparison. Data by size, see, in the case of OLTP, it's megabyte to gigabyte, but here it is gigabyte to terabyte, to even petabytes. So this is the classification of data warehouse users. Based on the computing proficiency, I can have casual or novice users, regular users, and power users. What are power users? Let me tell you. These users are well versed and highly proficient with technology. They are capable of creating reports and executing queries on their own, and can even write macros and scripts for the applications. And based on job functions, we have got executives or managers, technical analysts, and business analysts. Executives and managers, they need information for making high-level strategic decisions. They prefer customized and personalized reports. Whereas technical analysts, they perform complex analysis and statistical analysis. They perform drill down, roll up, slicing, dicing, which are nothing but overlap operations on data. And business analysts, although these users are comfortable with your technology, they may not be able to write queries and create reports from the scratch. So these business analysts, they rely on predefined queries and reports to satisfy the information needs. And lastly, business analyst framework in a data warehouse. So see, having data warehouse offers the following advantages. Since a data warehouse can gather information quickly and efficiently, it can enhance business productivity. A data warehouse provides us a consistent view of customers and items. Hence, it helps us manage customer relationship. CRM is very, very important in the case of data warehouse systems, in the case of any organization. A data warehouse also helps in bringing down the cost by tracking trends, patterns, or a long period in a consistent, reliable manner. So this is all for today. I'm sure you understood the ETL process, the data warehouse applications, with the business use, the strategic information, the importance of strategic information, and so on. That's all for today. Thank you. If you enjoyed learning, please do like and subscribe my channel. Jai Hind.